So in this last video, I'm going to talk about constructive and destructive interference in sound waves, as well as the Doppler effect. So remember that constructive interference is when two waves come together and their wave amplitude adds. So in terms of sound, this means that the sound would actually get louder. Whereas if we see destructive interference, the wave amplitudes are actually going to subtract from one another, and we would hear a softer sound or some sort of noise cancellation. So I'm going to show you a quick simulation of sort of this effect. So here you can see, I'm going to turn the frequency down so it's a lower note because it's easier to observe. And here is the observer, and you can see that over here there's some some overlapping of the waves coming from these two speakers, so we should be able to find some places where we experience constructive and destructive interference. Okay, so let me turn the audio on here. So you can hear the note, and if I were to move him around, you hear positions where it gets quieter here or it gets louder. Okay, and that's a result of the interference that's happening between these two waves. Now, if you're in a room that doesn't have very good acoustics and you're playing music, this is what can happen: is you can be, as an observer, you can be in a position where you might hit dead spots or spots where it's really loud. There's also the possibility of the sound reflecting off the walls, and then a whole bunch of interference happening here, or different notes coming to you at different times, and then the sound is very sort of muddled. And so that's why concert halls are designed in a certain way in order to eliminate interference patterns. Alright, so the last thing I'm going to talk about then is Doppler effect. So remember that Doppler effect is when a sound emitter or observer have some sort of relative velocity. And so if a person or a sound emitter are moving towards one another, it's going to smush the wave up, causing the frequency to be a lot higher and the wavelength to be smaller in between the observer and the sound emitter. Whereas if you're moving away from each other, it stretches that wave out and you have a longer wavelength and therefore a lower frequency. And in terms of frequency, remember frequency is pitch, or the note that you hear. So if we just turn this guy on again, you can see I can adjust the frequency here. I can make it a very low note, or I can increase it to a much higher note. Okay, so that's what someone would be experiencing when they are observing the Doppler effect. And I'm actually going to show a quick video, and the video is a little fuzzy, but you can really hear the Doppler effect that happens as a result of the siren. So there's going to be a fire engine coming from this end, so it's moving towards the observer, and then it will pass the observer and start to move away, and you'll hear a distinct difference in the pitch or the frequency of the sound. Okay, so you can definitely tell that as the fire truck passes the person, that there's a very distinctive change in the pitch, and that is a result of the Doppler effect.